Problem 5. Summation n is equal to 5 to infinity of the square root of n over n squared plus 5. You kind of see a p-series in there, but you have a lot of other pieces of algebra that kind of mess it up. So we're thinking limit comparison. And you're going to be right, but the biggest part of this problem that causes difficulty is what are you going to compare it to? Often students will just erase that square root of n and say, well, I'm going to just compare it to 1 over n squared, which is really tempting, but unfortunately it's wrong. Instead, we need to consider that n to the half power on top has an influence on n squared. So we are going to compare this to n to the half over n squared. If we subtract exponents or reduce that fraction, we get a comparison to 1 over n to the 3/2 power. So doing a little mini proof, we have part A, that 1 over n to the 3/2 power is a p-series. Part B is p is 3/2, which is greater than 1. And part C is we have the summation of 1 over n to the 3/2 power converges. And now for the limit portion, we have the limit as n approaches infinity of 1 over n to the 3/2 power over n to the half power over n squared plus 5. We flip those fractions upside down, we get limit as n approaches infinity of n squared plus 5 over n squared is equal to 1. Now make sure you don't stop here and just say I've got the answer. You have to then make a statement about why does 1 prove anything. So we go to the final step, which is to say that 0 is less than 1 is less than infinity, or you can say that 1 is positive and finite, which gives us the conclusion that the unknown series, summation n is equal to 5 to infinity of the square root of n over n squared plus 5, converges to, and to your calculator, you get a solution of 0.6195 rounded off.